Have you ever wondered where the universe came from or how it came into existence? It's a question that has intrigued mankind for centuries. Today, we'll embark on a journey back in time to explore the prevailing hypothesis about our universe's birth, the Big Bang Theory. This theory provides an explanation of how our universe, once a hot, dense point, started expanding and cooling around 13.8 billion years ago. Our journey begins nearly 14 billion years ago, with a phenomenon we now call the Big Bang. The Big Bang, contrary to its name, wasn't an explosion. It was the moment when the universe, initially a hot, dense point, started expanding. Dive with me now into the depths of the cosmic history to a time when everything we know, stars, galaxies, even space and time themselves, were compacted into a single point of unimaginable density and heat. This was the singularity, a point of infinite density and temperature. Let's pause for a second to grasp the enormity of this concept. Infinity is a difficult concept to comprehend, but in this context it refers to a state of being so dense, so hot, that our conventional laws of physics simply break down. Now you might be wondering, how did this singularity lead to the universe we know today? Well, imagine this singularity as a seed, a cosmic egg, if you will, containing all the matter and energy of the universe. Then, around 13.8 billion years ago, this seed began to expand. Not an explosion but an expansion, a stretching of space. This was the Big Bang. In the smallest fractions of a second, this expansion happened at an incredible speed, faster than the speed of light. The universe ballooned from the size of a single point to something billions of miles across. As it expanded, the universe also cooled. From a state of infinite heat, it cooled down to a temperature billions of times colder. This cooling allowed the first particles of matter to form, setting the stage for the formation of atoms, stars, and eventually, galaxies. It's important to remember that the Big Bang isn't just an event that happened long ago. It's an ongoing process. The universe is still expanding, still cooling, and every moment new stars are being born, and old ones are dying. A cosmic dance of creation and destruction that continues to this day. So, from this hot, dense point, the universe started to grow and cool, setting the stage for everything that exists today. The universe didn't stop expanding after the Big Bang. On the contrary, it has been expanding ever since. Imagine a balloon inflating. As it gets bigger, every point on the surface moves away from every other point. That's a simplified way of understanding how our universe expands. It's not that galaxies are moving through space. Instead, space itself is what's expanding, carrying galaxies along for the ride. This means that, from our perspective, it looks like every other galaxy is moving away from us. Now, how do we know this? The evidence is in the light. We know light can behave as both a particle and a wave. When we talk about the color of light, we're talking about its wavelength. Shorter wavelengths correspond to bluer light, and longer wavelengths correspond to redder light. Here's where it gets interesting. When a source of light is moving away from us, its light appears to be stretched out, shifting it towards the red end of the spectrum. This is known as redshift. So when we look at distant galaxies, we find that their light is redshifted. It's more red than we would expect if they were stationary. This tells us that they're moving away from us. The further away a galaxy is, the faster it appears to be moving away. This relation between speed and distance is known as Hubble's law, named after the astronomer Edwin Hubble, who first observed this phenomenon in the late 20s. Now, if we rewind the cosmic clock, following the paths of galaxies back in time, we find that they all converge at a single point around 13.8 billion years ago. This gives us the age of our universe and the starting point of the Big Bang. So it's the expansion of the universe, evidenced by the redshift of light from distant galaxies, that supports the Big Bang Theory. It's a concept that truly stretches our imagination, taking us back to the dawn of time and the birth of the cosmos. The universe's expansion is a key piece of evidence supporting the Big Bang Theory. The Big Bang Theory isn't just a historical concept, it's a living, breathing model that scientists use to understand the universe. In the grand scheme of things, the Big Bang Theory is far from being a dusty old relic of scientific thought. In fact, it's more relevant today than ever. Scientists continually use this model as a framework to make sense of the universe around us. It's like a roadmap, guiding us through the cosmic terrain, helping us navigate the mysteries of the cosmos. But what does it mean to say that the Big Bang Theory is a living model? Well, it's not static or unchanging, it's dynamic. It evolves, it adapts. As we gather more data about the universe, as our telescopes peer deeper into the cosmos, we refine and adjust the theory. The Big Bang theory of today is not the same as it was 50 years ago or even 10 years ago. It's a theory in motion, moving forward with each new discovery. Take, for instance, the discovery of dark energy. This mysterious force, which seems to be driving the universe's expansion at an ever-increasing rate, was not part of the original Big Bang theory. However, as observations and data have accumulated, the theory has adapted to incorporate this new aspect of our universe. Moreover, the Big Bang theory continues to be tested and challenged. Every new observation, every piece of data, is a potential test of the theory's validity. For instance, the precise measurements of the cosmic microwave background radiation, the faint afterglow of the Big Bang, have provided some of the most stringent tests of the theory. And so far, the Big Bang theory has passed these tests with flying colors. In conclusion, the Big Bang theory is not a finished product. It's a work in progress, a living model that evolves and adapts as we learn more about our universe. It's an ongoing conversation between scientists and the cosmos, a dialogue that helps us unravel the universe's deepest secrets. The Big Bang theory is our best explanation for how the universe began, but it's always evolving, just like the universe itself. So, why does the Big Bang theory matter? Why should we care about the universe's origins? Well, the answer is surprisingly close to home. When we look to the cosmos, we're not just gazing at distant stars and galaxies. We're also looking back in time, witnessing the very origins of our universe. The Big Bang theory isn't just a story about the universe, it's a story about us. Understanding this theory is like reading the first chapter of the grandest book ever written. It's the prologue to our existence, the opening scene of a cosmic drama that has been unfolding for nearly 14 billion years. By studying the Big Bang theory, we're not just learning about the universe's past, we're also gaining insights into its future. The universe is in a constant state of change, evolving and expanding with each passing moment. The more we understand about its origins, the more we can predict where it's headed. But this theory does more than just satisfy our curiosity. It also has practical implications. For instance, it helps scientists develop new technologies and make discoveries that can benefit society. It informs our understanding of physics, fuels our technological advancements, and even shapes our philosophical and existential debates. So, in a very real sense, understanding the Big Bang theory is understanding ourselves. It's about knowing where we come from, what we're made of, and how we fit into this vast, ever-changing cosmos. It's about appreciating our place in the universe, recognizing our insignificance in the grand scheme of things, and yet marveling at our ability to comprehend it all. In conclusion, the Big Bang theory is not just an abstract concept. It's a vital part of our quest to understand the universe and our place within it. It's a testament to our curiosity, our ingenuity, and our relentless pursuit of knowledge. As we uncover the universe's secrets, we're also unraveling the story of our own origins.